What is LLMOps? Basically, it's machine learning operations with regards to large language models. I want to serve thousands, but could be millions and hundreds of millions of requests of users. I want to make sure the system is 24/7 available and there's no downtime. And just spending money on infrastructure and on tokens and all that unnecessarily. I want to make sure I'm doing this in a cost optimized fashion, right? We're going to be looking at a production grade API. So we're going to be building an automated deployment pipeline. Also, we want to make sure that the infrastructure we use to deploy to production is scalable. And we want to make sure we have tools that allow us to monitor. Small introduction about myself. My name is Alias Harun. I'm currently based in LA. I work at Amazon. I'm a software engineer. I took on different roles, like as a software engineer working with different technologies, as a backend developer, iOS developer, as well as currently more of an MLOps engineer in the Amazon fashion org, working in the search ranking team. What is LLMOps? Basically, it's machine learning operations with regards to large language models. This is LLMOps, which is this set of practices that allow us to productionize machine learning models, LLMs in this case, the whole cycle from taking an experiment and going to production. An experiment where the goal of that practice was just to solve a business problem using machine learning. And we're going with that to production, where we want to serve millions of users in real time. We want to make sure the system is always available, no downtime, and all that. So what allows us to do this is those set of practices that come with tools. And of course, some of them are inherited from DevOps that allow us to do this in production.
If you are liking this video, then you love what I have to say next. You can spend months learning agentic AI or cut that time into half with a structured program by Interview Kickstart, where you actually build and ship 2 AI agents into production with a mentor from Faang guiding you through every step. It's called Agentic AI Career Boost Program. And if you think it's just another generic course, spoiler alert, it's not. It's customizable depending on your domain. Engineers, you have a Python-based AI engineering path. If you're a PM or a manager, you take no-code, low-code use case path. And both paths could be paired with Faang interview prep for AI-driven roles. But the best way to learn more about this program is through the free webinar. Here you can get all the details about the program, ask your questions, and see if it's the right fit for you. And if it is, you'll be joining a company of 25,000 professionals who have already leveled up through Interview Kickstart. Many now at Faang, Anthropic, OpenAI, already crossing 300K plus. And here is what some of them say. I'll put the link to the free webinar in the description, as well as pin it in the comments so you don't miss it. See you all there.
Okay. So we have two kind of worlds in this case, where we have the research and development, which has its own practices, its own tools, and production. Some to mention here in development, when we're trying to solve the business problem using machine learning, we would be using tools like Jupyter Notebooks. Jupyter Notebooks, they're kind of a tool, an IDE that allows you to run code and to share that code and to install everything you want in terms of like dependencies and access certain hardware as well. Like if you want to train a model and you need GPUs, you can connect that Jupyter notebook to a GPU. A famous example of a tool like that is Google Colab notebooks that allows you to do this. And for anyone starting in ML, I highly recommend it. It's part of Google Drive. You can create notebooks and you can access actually strong hardware for free within limitations. When we're working on the experiment, we don't care about scale, right? Because all I care about right now is solving that business problem using machine learning approach. So as long as my experiment works, it's solving that problem, that part is achieved, right? And all sort of testing that I'm doing at that point is just manual testing. I have my test data set. I have a set of scenarios that I want to test with. I do some manual validation. All that is done manually. Now, in contrast to production, where I want to serve thousands, but could be millions and hundreds of millions of requests of users, I want to make sure the system is 24/7 available and there's no downtime. And also, I want to make sure that I'm not just doing this and just spending money on infrastructure and on tokens and all that unnecessarily. I want to make sure I'm doing this in a cost optimized fashion, right? And lastly, I want to make sure that just any piece of software that I deploy, I want to make sure that this software is operating at an optimal capacity and that there's nothing wrong going on behind my back. So, how do I do this? With monitoring. All right. So, what we're going to be building today or looking at the demo, we're going to be looking at a production grade API. So, we want to deploy a machine learning model, an LLM, in real time for real time inference to generate predictions in real time. An example of that would be, you're talking to ChatGPT and you're sending requests in real time and you're getting the response in real time, right? Also, for that, we're going to be building an automated deployment pipeline where whenever I push code, I want this code to build, to be tested, to deploy to production all in one pipeline, all in one run. I don't want to be interfering with that process. Also, we want to make sure that the infrastructure we use to deploy to production is scalable. It's something that will allow us to serve a large amount of users. So we want it to auto scale. And we want to make sure we have tools that allow us to monitor our software. Okay, we'll dive deeper into the different tools and all that. All right, so let's talk about some concepts here and tools. So one of the main tools that we're going to be relying on when we're talking about MLOps or LLMOps is Docker. Docker is an amazing tool that allows you to package your application with all its dependencies in one unit. Now, why is this important? Well, I'm sure you've run into the issue where you're working on a project, you pass this project to a colleague, they try to run it on their machine, and they run into the issue where it's not running. Why is it not running? They're missing some dependencies. The version of this module on their laptop is not the same one that you have, and or the underlying one, like downstream in the dependency graph, is not the same one. So you're running into this issue where it's working for you, it's not working for them. So what Docker allows you to do is you package the application alongside the dependencies and everything that it needs to work so that when you pass it along to someone to work on or to run it, it will run regardless of their machine or operating system. So I take a look at that. Okay. Now, Docker, as I said, is this amazing tool. It will allow you to run your application with all its dependencies. And when you run it, you create basically a running container. When you build your application with all its dependencies, we're talking about an image. So the image is that blueprint that you package everything with. That's like the recipe. And then when you run it, you have a running container. Think about it like in object-oriented programming where you have a class definition, and then when you instantiate it, you have an object. So when you have the image, you instantiate it or you run it, you have a container. Now, in order to create the image, I need to specify my recipe. I need to write it down somewhere. I need to say, I want in this image to include this code, these dependencies, this version of Python, and so on. So where do I do this? We do this in something called Docker file. So you define your Docker file and it has this recipe. Okay. Now, when I run my container, and think about the container here that it contains basically a running server that will serve external traffic and will contain my model. So an external request comes in, the container will go to the model for inference to generate a prediction and will return a response. Now, if I have a single container, I'm limited to the amount of traffic I can serve. I'm limited to the number of threads and processes that I can spin up, right? So in order to scale up and to be able to serve a large amount of traffic, we need Kubernetes. Kubernetes is an orchestration framework for Docker containers, and it's basically the maestro of this orchestra that would be a series of containers running and interacting and serving traffic in a very organized manner. So Kubernetes will allow you to orchestrate all these running containers, but not just orchestrate the running ones. It'll handle so much more in terms of scaling. It'll handle redundancy. So you have multiple containers running the same code in case you have a lot of traffic. It'll handle failed containers. So if you have a container that fails, it'll spin up another one. And it's not really a container that it spins up a pod that has a container. That's the smallest unit in Kubernetes. And it handles autoscaling, different types of autoscaling. It handles load balancing. So imagine you're just creating this entire fleet that is running and is self-maintained, where it handles failures and all that. And that's what Kubernetes gives you. Another concept here in LLMOps is CI/CD. So whenever we're going from experiment to production, we want to make sure that any changes that you make to any of the code that's involved in the process is fully automated in terms of testing, building, catching bugs, code quality, and all that, but also that it propagates through the different stages that serve your different clients. And by clients, I mean internal clients and external clients. So let's go through CI and CD. So CI is continuous integration, where I have the automatic code building and testing upon every commit. Okay. And once I build my code, I run unit tests, I catch bugs, I make sure code quality is optimal. Now, what comes after? We have continuous deployment, where once that is done, once the integration is done, now I'm moving this code through different stages. For example, I move it to the beta stage. What's happening in beta? I'm running the container, and I'm also running integration tests against that running service. So beside my unit tests that I ran during the build, I'm running some integration tests to make sure the entire end-to-end flow is working fine. And then the next stage would be, for example, a gamma stage. A gamma stage would be where I'm running my canaries, load testing the service. And then the last one would be production. Now, in the continuous integration, or as part of that integration, we can do much more than what's listed here. We can, if we're dealing with a Docker image, for example, we can build that image. We can push that image to a registry. We can run any sort of security testing on that image as well. So we can do a lot more, all as part of this CI/CD flow. And we create, basically, in this scenario, we create a CI/CD pipeline. We're going to be talking about this more later, but this is just to tell you that when we mentioned Kubernetes as this amazing orchestrator for my Docker containers, there's a small requirement here, is that I host this Kubernetes cluster. So when we create Kubernetes to manage a series of containers, we create a cluster, and this cluster needs to be hosted somewhere. So I have to provide the hardware and host it. But we have other solutions where you have managed Kubernetes. And this is an example here through Amazon EKS, Elastic Kubernetes Services. And basically it hosts that cluster for you, and all you have to manage is the nodes in that cluster. And everything else in terms of setup, infrastructure, observability is actually handled for you, which is amazing. But this is similar to pretty much any service that's provided by a cloud provider. They abstract all the infra setup and all that annoying setup, and you just focus more on your application. So this is kind of like a luxury if you can use that. Now, with Kubernetes, we can run into this mess of managing configuration files, because for every change and every small component of Kubernetes that you want to update, you have to create a YAML file concerning that component that you want to update. So it can get messy, especially if you have a complex cluster. But luckily, we have a solution for this that we will also use today, which is Helm. Helm is basically a Kubernetes package manager, and it handles all these YAML files for you in a very nice way, and it does cross-reference between them, and it allows for easy upgrade, rollback, and initial install as well. So it's a pretty good tool to use. Now, for monitoring, this is something you want to do to any software that you deploy and you put between the hands of your customers, right? It's not necessarily specific to machine learning or machine learning applications. So this is something you definitely want to do. Examples of tools to do this, we have Prometheus to emit and collect metrics, and you have Grafana for visualizing these metrics and dashboards and all that. But you're not limited to these. If you're also doing work in AWS, you have, for example, CloudWatch. You can do all that through CloudWatch as well. Okay. So when we're talking LLMOps, in today's section, we're just focusing on the deployment, but MOps is not just the deployment, it's the entire process. It's productionizing the entire process from collecting data, processing the data, feature engineering, and deploying the model somehow. In this case, if we're deploying in real time, then we're deploying it as a service and it's serving traffic in real time. But also, you can have a model deployed for batch inference, which is running as part of an offline pipeline. So, depending on the use case. But here we're focusing on this section where we have an already trained machine learning model and we just want to serve it, put it in the hands of our customers. All right. Just want to see a couple of questions here. Will the same MLOps tools like MLflow work for LLMOps as well? Yes, definitely. MLflow is agnostic of what you want to do. So it allows you for experiment tracking, for training and tuning and model versioning, all these components that you used for in MLflow, you can use for LLMs as well. Are these enterprise grade recommendations? Yes, definitely. All right. So focusing more on the demo and the tools that we're going to be using for the demo, and that will help answer one of the questions here as well. So for serving the model, as I said, we want to build this backend service that exposes the model through APIs that the customers can call. And we will be using a tool called BentoML. Now, you probably heard, because we're doing it in Python, you probably heard of Flask, of Fast API, but we're choosing to do BentoML. And BentoML is actually more optimized for serving machine learning models, where it has built-in model versioning. It has automatic API generation where you don't have to explicitly specify the APIs, the status codes, and all that. It's optimized for production where you need to consider cases like batching and caching. If you are experienced with, or if you have some experience with deep learning models, you can specify the batch size, for example. And what that allows you to do is basically, let's say you're trying to predict what's in that image. So instead of processing one image at a time, you can create a batch of 200 images and you're basically running inference on a single batch that contains 200 images. Now, when you're serving this in real time for behind a server or inside the server, you need to implement the logic that basically takes in the 200 requests, aggregates them, and passes them to the model. Now, if you were doing this with something other than BentoML, then you will be doing that. However, with BentoML, it's just a single line of code that handles all that for you. You just tell it the batch size, and it handles the batching for you, for example. You see how it's optimized for machine learning applications rather than just building a server for a generic use case. Also, it handles containerizations. Remember, we spoke about Docker and how I want to package my application inside a Docker image and run it as a container. Now, with BentoML, using BentoML command line tool, I would be able to containerize directly. I don't need to handle Docker commands, so it's all done with BentoML. Okay. And it integrates easily with monitoring tools as well. All right. Another thing is that it allows you to declare resources that you want to allocate to your service, like number of CPUs, memory, and all that. This is something that you might not be able to do with other frameworks. All right. And also, it includes some APIs that are kind of baked in already, like a health check API, where you basically have the server / health Z that gives you access to the health of the service. Now, having said those, it doesn't mean that it's abstracting everything for you so you don't have granular control. The beauty of it is that if you want something easy, deployable, thank you, Ron. If you want something easy deployable with minimum configuration, you can definitely leverage those out of the box features, and it allows you to spin up a service that's fully running and it's handling everything for you. But also, it allows you to have this granular control if you want. You can define your own health check API or more custom API. So the sky is the limit with this. Yes, it includes GPUs. So we have a question, does the service resources management? Yes, it does. For CI/CD, you can use Jenkins as well. Yeah. Something to mention here is that you're not limited to whatever I'm going to mention here, but whatever I'm recommending here is industry level tools. It's not just for like a quick prototype or anything. So you can use these and you can use definitely others. There's plenty of other tools that are there. And I encourage everyone to experiment and see what works for you, for your use case. Some tools offer a lot, but like the setup is too complex. It's an overkill, so you might want to go a different route. Okay. Another thing that's important when we're going from experimentation to production. Well, what is it? In experimentation, I'm working in notebooks. I'm saving that notebook. I'm giving it to another scientist or MLE, and they're continuing to work on it, or they're rerunning my experiment and all that. However, when we're moving to production, we're not dealing with notebooks anymore. We're dealing with Python code. I need to implement everything in Python. I'm dealing with, because I'm using BentoML, I have BentoML configuration file, which is BentoML YAML. I'm defining my dependencies as a list of dependencies in a requirement text file, and so many more configurations. So I want to make sure all this configuration is versioned, is auditable if there's any change. And the way to do this, most of you have used it, I'm sure, or have heard of it, is Git. With Git, I'm able to version all this code and much more, and keep track of all the changes and roll back to specific changes and take action based on different commits, based on different changes that I'm pushing. Right. Another thing, it's with Git, you're able to create branches, which allows you to maintain the main code on a main branch, whereas you have a feature branch where you're experimenting with a new feature before you merge it back onto main. So when you go production, going with Git is a must at this point. All right. And what we spoke about, we're going to be using Docker here to package our application and run it as a container, with the benefit of dependency isolation and being able to run on any cloud provider if we're going with cloud providers, or even locally on any machine. And again, because we're using Kubernetes and we have for this demo the luxury to use EKS from AWS, we're not going to be hosting our Kubernetes cluster. We're going to be using AWS EKS that will host this cluster for us, and because Kubernetes will handle the auto scaling for us, self-healing, load balancing, allowing also any changes to have zero downtime deployments. All right. Now, we had a question on CI/CD and using Jenkins. As I said, you can. It's not the only one. In this demo, we're actually using GitHub Actions for automating this entire pipeline. And with GitHub Actions, what happens is when I push code, I'm able to trigger build and building of the image, deploying of the image, or pushing the image to a container registry, and then updating Kubernetes cluster with the latest code so that it reflects on the client side, so that customers can see the latest changes. Okay. So all that is going to be orchestrated with GitHub Actions. And we're going to go through all these steps together. All right. Just looking at the questions here in Q&A before we move forward. Gaurav, I'll answer you towards the end. So we have a question on BentoML and SageMaker deployment. When you say SageMaker deployment, I'm assuming you're talking about SageMaker endpoints to deploy models for real-time inference. You can go either route. If you have also the luxury to go with SageMaker endpoints, I've used it in the past. It does the job. But also, if you want to have a more granular control, also if you don't have access to all these AWS services, you can do BentoML and define your own APIs as well. All right. So continuing on this, what are we going to be using for our demo? Well, because we're using Kubernetes and we have all these YAML files that are used to update our cluster, we don't want to deal with all these YAML files. And here's an example of some of them. We have deployment YAML, which usually contains the pod configuration. You want to mention there what replicas you have. I want, for example, 2 replicas of my pod, and I want a minimum of 2 pods and a maximum of 10. So basically, if I'm scaling up, I'll go all the way up to 10 replicas. And by replicas here, we mean we have pods running the same code so that if we have more traffic, we're able to serve that traffic. Service YAML is the configuration for the networking. What type of load balancing I'm going to be using. And we have different types of load balancing that could be configured for Kubernetes. HPA, horizontal scaling, basically what type of auto scaling you want to define, and the basically all the configurations that go around that. Like when do you want to auto scale? Maybe when I hit 70% of my CPU and so on. All right. Now with Helm, you can define, all you have to define is the values YAML. and the initial charts. So in Helm, you have a charts YAML, which just general information, but the core of your configuration is going to be in the values YAML, and the rest is auto-created for you. All these deployment service, HPA, and many more configurations are auto-created for you by Helm, which is amazing because you don't have to create those. All you have to do is define your values for what needs to go in those configurations, and the rest is handled for you. All right. And once you have your values and your charts YAML files, all you need to do is Helm upgrade, install the name of your service and where your charts reside in your repo. And that will create everything for you and does all the referencing between them. And it saves you a lot of time. All right. Now, monitoring, observability. What are we going to be using for this? We're going to be using Prometheus and Grafana, and we should be able to see information about our cluster, CPU usage, memory usage, and much more. It depends on the metrics that you get to define for your running application. In our case, we're going to see CPU metrics, memory, and also the requests coming to our application. All right. So just to summarize and revisit the big picture, we have a local development happening locally. And then once we create a git commit, and push it, is going to trigger GitHub Actions, which will build the Docker image, push it to ECR. ECR, and I haven't mentioned that before, ECR is Elastic Container Registry. It's a container registry that is provided by Amazon. It's a private registry that you need authentication to access it. And we're basically storing our Docker images over there. It's not the only one. You can use other registries, but that's the one we're going with today. Okay. And once we build and store our image in ECR, we're going to update our Kubernetes cluster with the recent changes, which will reflect those changes through our Kubernetes service that our user interacts with. All right. And because we have Prometheus and Grafana configured, we should be able to see some of the metrics about our cluster and the interaction that the user is having with it. Now, because we're limited on time, I had to do some setup beforehand. So I deployed the EKS cluster already with 2 nodes. I set up BentoML service and GitHub Actions, the Helm's charts, and everything is set up. Now, you have access to all that in my GitHub repo that is already, I believe, shared with you. If not, it will be shared with you after the session. And I have all the instruction that you need to replicate what I'm doing here. But we're going to go through all that at least in this session. All right. So let's do a quick high-level overview, and we will then go deeper into code setup and all that. All right. So this is the GitHub repo. And whenever we're pushing something to this repo, what happens is we actually trigger GitHub Actions. Now, when you see GitHub Actions, it's a set of steps that are executing sequentially. And we're going to go through the code for those, but it's a series of steps that execute sequentially that will eventually push the image to ECR, Elastic Container Registry in RDS. And we can see in this private repo that the image is pushed. And once it's pushed, as also part of the GitHub Actions that are running, it deploys to EKS. So it updates the Kubernetes cluster with the latest image. And here we have my cluster running, and you can see different information about the cluster here. Let's see. You can monitor the cluster as well through here. Cluster health, control in monitoring. Okay. So all that is provided by AWS. However, you can also still implement your own external monitoring system, right? Through Prometheus and Grafana, as we said. Let's see. For some reason, the metrics are now populating in the dashboard here. It's showing no data. It was running up until I restarted the cluster today. But what we would see here is basically the CPU utilization, memory, and the requests coming to the cluster and much more. And you can define more metrics. Like, for example, you want to monitor the length of the prompts, how many tokens, and all that. So in our case, we're using an LLM that is hosted and is serving traffic in real time. And we want the users to interact with the LLM, similar to how people talk to ChatGPT and write prompts and get responses, right? So you want to monitor tokens and other metrics, you can do that here as well and be able to visualize it. Maybe to fix this, I just need to restart the cluster or something, but we're gonna move past that just for the interest of time. Now, just for the quick demo, I have this small front end built as well, and all the instruction to run it is in the repo readme as well. You can do that. So similar to chatting with like ChatGPT or Claude, tell me about yourself, generate response. And it says, I'm a fan of Rick and Morty. And that's actually a response from the model. So we're going to see the model that we're using. It's just a medium size LLM from Microsoft. And yeah, it has a sense of humor. And this is not a funny response, but I got a lot of funny responses from it before. And for all Rick and Morty fans like myself, that's good to see that the model is a fan as well. Perfect. So this is at a high level what we have. We have this fully deployed service that I'm able to interact with and many people can interact with because it's scalable and we're not going to run into issues. It can scale automatically because we're using Kubernetes and it's deployed on EKS. And if I want to make any changes, I can make changes to my code, push it. GitHub Actions will take care of building and deploying these changes to the service. Now, let's do a deep dive into the different components that we have. Perfect. Do I need to make it larger or is this good? Is this good enough? That's fine. Perfect. So we have different components. Yes, please. Sure. So in this repo, you'll see we have different components. The first component is we have to build our BentoML service where I'm using BentoML to create my service and define my APIs. Now, first thing you want to do is to load the model. So I'm using a pre-trained large language model and I'm loading it and serving it in real time. The model we're using is Microsoft Dialog GPT Medium, and this model is coming from Hugging Face. I don't know if you're familiar with Hugging Face, but let's Hugging Face. But on Hugging Face, you have access to all sort of models and data sets and the community as well to get some answers and all that. And they have a lot of courses as well. So feel free to look into it and use the free tools that you have here. You can even host some code on Spaces that's provided here. So the model that we're using is Microsoft Dialog GPT Medium. And if you visit that page on Hugging Face, you can actually see more information about this model and how it was trained. Maybe depends if the model is like open source or no. You can see maybe the scientific paper behind it and all that. And some models depend, let's see. Oh, I can't use it here. But on some models, you can actually, they give you like an interface that allows you to prompt it and to try it out to see for yourself. And yeah, it's pretty cool. And this is not the only model that you can use. You can choose any model from Hugging Face. If you go under models, you see text to speech, text generation, all sorts. Okay. Now, to use it in Python, all you have to do is import the transformers library from Hugging Face and pass your model name to it. Now, also Hugging Face gives you the tokenizer for that model, which is important to transform the input that you get from the user into input that the model can understand. Okay. Now, first step, as I said, all we want to do is load this model. Now that the model is loaded, when we say loaded, it's loaded in memory, ready to serve traffic. Now we define our generate API. And the generate API is this method that will take a prompt, which is a string from the user, similar to what I was passing here, and will encode this input. And by encoding here, we mean because the model is not going to understand text directly. The model will first, or the application will take text, convert it into token IDs that actually point to the vocabulary in the model's vocabulary, and that would be the input for the model. And then all you need to do is call model generate. You set different configurations for that specific model, like temperature, top P, and other configs, and then you get your output. Now, when you get your output, in order for us humans to read it, we need to decode it, convert it from token IDs, which is basically like an array of numbers to actual words. Okay. And once we have the full text, we can display it to the user. All right. So this is my service. All I have is a method to load the model and a method to generate a response from a prompt. Okay. Now, you're not limited only to those methods or these APIs. For example, here I have implemented a health check method. Even though BentoML provides you with a built-in health, it's usually at health Z, but in my case, I wanted maybe to do some more. I wanted to customize more, and I wanted to actually dump more information in the health check. So you can do that as well. Okay. Now, this would be the core logic for my inference, which is generating predictions. Okay. The next thing we have is, all right, so I have my code now. I want to, remember we said we want to use Docker and we want to containerize and all that, but we're not going to do it directly. We're not going to write our recipe file, which is a Docker file. We're going to do it through Bento. Remember, BentoML provides you with the ability to containerize your application and serve it. And that's what we're going to be using. We're going to be using a Bento file YAML, which contains some instructions on how to package this Docker image from BentoML. So we're telling it include the source file, Kubernetes directory, which contains basically my YAML files for Helm. And we're going to talk about that in a bit. And my requirements txt. So what's in requirements txt? It's a list of my dependencies, my Python dependencies that I need to run this application. Okay. I have BentoML, I have transformers, torch, PyTorch, tokenizer, and others. Okay. So I also have the base version of Python, or the base image of Python that I want to be using for this application. So this is what I include in my Bento file YAML, and this is required for BentoML to containerize my image. Now, the next thing is values and charts. So remember, we're not just containerizing this image, we want to deploy it to be orchestrated for Kubernetes, right? So to be orchestrated by Kubernetes. And to do that, we need to create different YAML configurations for different components of our Kubernetes cluster. However, we decided to go the lazy route, smarter route, which is using Helm. Helm will allow us to manage these files and create some by itself. All we have to do is create the chart YAML file that just contains general information. And the important one is values YAML. And in this file, we have the number of replicas for redundancy. And we also have the image that we're reading from. We also have the service, which is the load balancing technique that we're going with, resource allocation, maximum, minimum per node, and also auto-scaling configuration. So I want to enable auto-scaling, minimum replicas 2, maximum 4 when I hit 70% CPU utilization. Okay, I'll get to your questions after this. And now I have my core code set up. I have my Bento file YAML, which allows me to containerize. I have my chart and values YAML for Helm to manage all the components needed for Kubernetes. Now I need to automate that process where whenever I push code, it goes all the way and deploys, etc. Now, to do this, you need to create a deploy YAML file, which lives under .github/workflows. And this contains basically your pipeline definition for your CI/CD pipeline. Let me just collapse these so we can go through them. So the first step we have here, so some of them are not like specific to this project. They're just general cleaning or maintenance steps. So the first one, I'm freeing some disk space, set up Python. Okay, so just removing some files to save some disk space, setting up Python to 3.9, installing dependencies, which are my requirement.txt dependencies, this list of dependencies here. So basically, this is what's happening in an automated fashion to be able to containerize this image and deploy it to ECR. So installing my dependencies, and now because I'm using ECR, which is the container registry for pushing my Docker image, it's a private registry. It's a private Docker registry. And in order to access it, I need credentials. I need to log in. So to do this, you need to also specify a login step in your pipeline. And if you notice here, something very interesting, that I need to log in. So I need my AWS access key and secret key, but I should not be in the region, but I should not be hard coding them in my code. Otherwise, if you go to my GitHub repo right now, you would be able to see those credentials, but you're not able to see that. Why is that? Well, because GitHub Actions actually allows you to store these configurations in GitHub Actions safely, secure, behind your GitHub authentication and two-factor authentication, and you just reference them here as such. Okay, so you keep your secrets in a safe place and you reference them here, and they're the responsibility of GitHub at that point to keep them safe for you. Okay, so this step, all we did is we configured AWS credentials, and then we log in to ECR to make sure that we have access to that repo that we want to push an image to. The following step is to build BentoML container and push it to ECR. And for that, we're using a BentoML command. As you can see here, there's the hovering thing. So you see here, we're using BentoML build. Now, if you're not using BentoML and you just want to containerize the application, you would specify your Docker file, and then you would do Docker build instead. Okay, but the benefit here is that BentoML allows you to do that on its own by doing bento build. And we're doing Docker, we're tagging and doing Docker push. So these are standard Docker commands to push the image. All right. So next thing we do is just also some maintenance, clean up Docker space. Otherwise, we run into some issues with GitHub Actions. And the next thing, we make sure we install a couple of tools here, which is kubectl and Helm. Helm, we spoke about it. It's to manage my YAML files and configurations for Kubernetes. But what is kubectl? Kubectl is also a tool used to push commands and push updates to the Kubernetes cluster. And in this case, I need it to be installed. Why? Because this is not running on my machine. When I showed you all these steps here, these are not running locally. These are actually running on some GitHub server that is executing these commands on my behalf. So I want to make sure that that GitHub server has kubectl and Helm, so I have to install them. So we have to add a step to install them, as you see here. Next step is, again, just, it's not really needed, but it's good to have. It's verifying that you have access to that EKS cluster that you intend to access and update before you go ahead and update. And the last step is to deploy to EKS, the latest image or the latest configurations as well. Okay. And these steps that you see here are the exact same steps that if I go to my GitHub Actions are getting executed here. And the beauty here is that when you make a change and push it to GitHub, you would be able to see this executing in real time. So let's actually do that. I'm going to make just a small change. So let's just add a comment here, for example, load model and tokenizer from Hugging Face. Perfect. Let's expand this to see what we're doing. So git status, I have this file that's changed. So I do git this file, git commit, and update documentation. Okay, so I created the commit, and all I need to do now is to push it to trigger that CI/CD pipeline. All right, so now it's pushed. If we go to actions, we see the latest commit showing here. It's showing that it's deploying, and it's actually going step by step, showing you the output of every single step that's happening here. Okay, so we're not going to wait for it to execute. It's just going to take 10-15 minutes. But other than that, this is the process to do this. And once that is created and updated, we're going to see a new image being pushed to my ECR repo, a new line basically being added here containing that image. And then we're going to see an update in our cluster. And if we made some code change that actually changes the behavior, we would be able to see that change reflecting. Okay, we're not going to worry about this part for now. But so yeah, we're pretty much done with the demo. It's just like some recommendations and best practices here. So for LLMOps, what are some good things to do? What are the best practices? Well, you want to make sure that you version your models and your model deployments so that you have a traceable or a lineage of what is the code that I used with which model version, with which Docker image that led to which deployment that users are currently using, right? And why do you need this? Because you want to make sure that when users are interacting with a specific deployment, you can actually know what model contributed to that, which code, which inference code, etc. Right? Because if there's an issue, you want to connect all that. Another thing that you want to be able to do is A/B testing before full rollout. So, for example, let's say we decided to use a new version of this model instead of the current one, and we want to roll it out. The last thing I want to do is to just change that model and push a new deployment. I want to do some A/B testing where I allocate a small amount of traffic for the new model, I collect some metrics, and the rest of the traffic to the old model, right? Another thing I want to do is monitoring the quality of the infrastructure as well as the service that's running. So through monitoring tools and the integrations that we saw today. Another thing is this is more of an optimization where if you're dealing with prompts, for example, for an LLM, like in our case, sometimes you might have common queries. So, of course, you're going to be monitoring the incoming queries from the users. And maybe as an optimization, you can, if there's no personalization involved in your model or in your service, where like you're including other information in the response that is making the response more personalized. If it's just general, like what we have, maybe you want to cache common queries. So you're not sending all the queries to the model, right? So you want to cache the response and return that. You want to introduce batching as well. And that's what I said earlier. With BentoML, you're able to batch requests to the model rather than having one request hit the model and another request hit the model. Now you can batch. And with BentoML, you should be able to do that. Security, pretty common sense. You don't want to hard code your secrets like I showed you here. Remember when we said we want to log into ECR to access, configure credentials. You want to use these placeholders, and let me show you actually where it references in GitHub. If we go to deploy, if we go to settings, in your repo, if you go to settings and you can see secrets and variables and you go to actions, you can actually see all these secrets that I configured in my repo. And these are the same ones that are being referenced here. So this way I don't have to hard code any secrets in my code. Also, because in this case we're implementing an API, you want to make sure you have, all these rate limiting for the API so that you don't get people abusing the service. And maybe you want to introduce authentication, also depending on the service that you're giving your customers. And also you want to make sure you have audit logging for any changes and to be able to trace any issues and be able to look into them later. All right. Common mistakes that happen with working with LLMs or real-time deployments like what we saw today could be not setting resource limits. So you're not working with tools like BentoML and Kubernetes allow you to actually limit the resources used by your service so that you can manage it in a better way. So you want to make sure you use that. Another mistake is not setting health checks or using the health check APIs. Another thing is, being happy that the service is currently working and not having monitoring for prod service. When this happens, at the beginning, you might be like, my service is working. I don't need to set up all this monitoring stuff. But then whenever an issue happens, you're just blind. You can't see where the issue happened and what caused it, and you'll regret it. Another thing is manual deployments. Something I didn't mention earlier is that all the steps that are happening here, all these steps, you can run them manually. I included all these instructions for manual testing locally and manual deployment and everything locally. I included them in the README file in the repo. You can actually do that. So if you don't want to go through the CI/CD. However, with CI/CD, you make sure that you don't make mistakes. It's fully automated and you avoid any issues due to human error. All right. And because we're using Kubernetes, and the whole point of Kubernetes is to orchestrate a scalable service for you, you want to use replicas. You want to make sure you have redundancy so that if one container, one pod fails due to some network issue, due to some whatever issue, some unhandled exceptions in your code or whatever might be the root cause. You want to make sure that you have other replicas running to serve clients, right? So these are common mistakes that are usually made. And yeah, so this is what we looked at. This is what we built. And once the code is shared with you and the slides, feel free to go through it again and try to recreate it. And yeah, I'm looking forward to hearing some feedback from you as well on that. Thank you so much.